graphs are a vital data structure or concept in computer science. And graphs have vertices and edges. You can see here at the bottom of the screen, we have four vertices, A, B, C, and D, and they have edges between them. Of what use is a graph? Let me give some examples here. So here is one of the classic uses of a graph. It's a graph of cities in southeastern Idaho. And each edge is labeled with the number of miles between the two cities. So I have Pocatello in the bottom right. There are 25 miles from Pocatello to American Falls, 88 miles from American Falls to Twin Falls, and so on. There are many interesting things we can see in this graph. One is I can't drive directly from Pocatello to Pingree. I either have to go through Blackfoot or through American Falls. There's no direct road. And furthermore, I can find the quickest way to get to Pingree from Pocatello by summing up the two paths, right? So going through American Falls, I can travel 25 miles to American Falls and then 36 miles to Pingree, which gives me, 61 miles along that path. But I can also try this path to Blackfoot, 25 miles, and then to Pingree, 15 miles, which would be many fewer miles, 40 miles. Now, we use this all the time. In Google Maps and other mapping software, it's going to give us the shortest path to a different city. And what it's doing is it's storing the cities as a graph and running algorithms on this graph to find the shortest path to get to somewhere. Here's another example of a path. These might be tweets. You might want to analyze tweets and understand what people are talking about on tweets and how the topics relate. So if I have a tweet that mentions politics, does the tweet also mention religion? And maybe 18 of my tweets do. And maybe only 2 tweets mention both pop culture and politics, whereas 10 tweets mention both pop culture and food. Now, there might not be even a single tweet that mentions politics and food in the same tweet, and so there's not an edge between politics and food, and similarly with religion and pop culture. And this is a powerful way to model the dialogue going on in tweet space. And one last example, there's the game called The 6 Degrees of Kevin Bacon. So some people back in the 80s or 90s decided that Kevin Bacon was the center of the entertainment universe, and they wanted to know if there were what kind of the connections there were between all actors and Kevin Bacon. It's called The 6 Degrees of Kevin Bacon. It's to find, given some actor, can you link up from that actor with another actor that was in the same movie, and from that actor to another actor that was in the same movie, and was that actor in with Kevin Bacon? So, for example, we have Brad Pitt here, and Brad Pitt was in a movie with Kevin Bacon. I don't remember what it is. It was recent, and so there's an edge between those two vertices because they were in the same movie. Now, Johnny Depp and Kevin Bacon were in a movie together. Marlon Brando has never been in a movie with Kevin Bacon. However, Marlon Brando has been in a movie with Johnny Depp, who was in a movie with Kevin Bacon. So Marlon Brando has 2 degrees of separation from Kevin Bacon. Similarly with Ginger Rogers, who starred in a movie with Elliot Gould, who was in a movie with Kevin Bacon. And so you can see that the uses of graphs are everywhere. They're ubiquitous. And so we're going to spend a lot of our efforts on graphs and their algorithms in order to be able to analyze these important kinds of questions, like how many degrees removed from Kevin Bacon is a given actor.